The Compare Tariffs app allows you to compare different what-if usage scenarios. In order to do that, you have to define some. The simplest what-if usage scenario consists of a single load profile. So that's what we're going to create in this video. To start, we're going to use this plus button in the bottom right-hand corner to create a new what-if usage scenario. When you create a new what-if usage scenario, everything is locked. The only thing that you can actually set is the name. I'm going to call this No Solar. Once you save this, the load profile icon is enabled. So the house is enabled. You can now click on it. The padlock has gone away. So I'm going to click on this and go into edit my load profile. The load profile consists of 4 tabs. It has some basic metrics, the amount of electricity you use in a year, your base load when everything, or what you think is everything, is turned off, everything apart the fridge and the freezer, your maximum import and your maximum export. When you also need to specify a distribution profile. We have 3 distribution profiles. So how you use electricity across the days of the week, across the months of the year, and across the hours of the day. You can edit these manually by adding or removing a percentage from each of these. And when you save them, it becomes apparent in the bar chart. A better way to do it, if you don't have access to that information, or a better way to do it if you do have access to other information, is to use a different distribution source. If I edit this, you can see that I'm currently using a custom distribution source. When I click on the custom distribution source, I get the option to reset the custom back to the way it was. I can use a standard load profile. These are published by ESB and the CRU every year. And I can use an ESBN HDF file if I have one. This is available if you have a smart meter. You can register with ESB Networks and download a HDF file and actually get your import and export directly from ESB Networks. So I'm going to show first the standard load profile, and I'm going to pick, there are 6 of them defined, and I'm going to pick the standard load profile for smart meters and urban. When I save this, I can then look at the distribution and see that it is in fact giving me a nicer daily, monthly, and hourly distribution. If I want to change this, I can also use an ESBN HDF file. This one is more interesting because it's more accurate. I've downloaded a HDF file previously. Here it is. And it has dates from the 6th of December to the 22nd of July. So I select the date range for which to use. So the 6th of December 22 to the 22nd of July. I need to move this out of the way. The 22nd of July, and then I save it. Once I've done that, I can set my load profile. It doesn't take long, but it tells you that it's done. So if I come back out of this, and I save it, I can now look and see this is a distribution protocol. It gives me my usage profile, much higher usage on Saturday. I have a very, very flat distribution here for August, September, October, November, because I don't actually have data for this. And my July is quite low, again, because I only had dates up to the 22nd. If I want to modify this, then I can increase these a little bit to make them hopefully look a little bit better. If I had a full year's HDF file, then this would be exactly what I needed. The hourly distribution is in fact appropriate for me because I purchase electricity in the middle of the night and don't purchase very much electricity outside of that time. Okay, and if I come out of my load profile editor, then the simulator will automatically begin to run. The simulator is visible down here. We have a circle progress bar, and now the simulation is finished, and you can see that it's given me a best cost and it's given me a load breakdown. It's also, you can see, unlocked the inverter, the water, and the EV. So these are things that I can now configure because I have defined a load profile. I cannot yet define panels or a battery because I don't yet have defined my inverter. So that'll be the next video. Thank you for listening.